Buoyancy is experienced by a body partially or totally immersed in a fluid, such as water. When a body travels through a fluid, it experiences a buoyancy force due to the displacement of the fluid. Buoyancy force can be expressed by FB is equal to PVG, where FB is the buoyancy force in newtons, P is the density of the fluid in kilograms per meters cubed, volume is V is the volume of the fluid displaced in meters cubed, and G is the gravitational field strength in meters per second squared. Let's look at this example to get a better understanding of buoyancy force. An iceberg floats with a large volume of ice beneath the water. Ice has a density of 917 kilograms per cubic meter and a volume of VI. The density of water is 1,020 kilograms meters per meters cubed. What fraction of the iceberg is above the water? Archimedes' principle states that the size of the force that produces is equal to the weight of the fluid displaced. So the weight of the iceberg would be Wi is equal to MIG, and the weight of the water, which is the buoyancy force, is the weight of the displaced water, which would be WW is equal to MWG. Now, since we know that the iceberg is floating, its weight is exactly equal to the buoyancy force. So we can rewrite it as MIG is equal to MWG. And now we can rearrange the density equation for mass. So M in these two cases would become PIVIG is equal to PW and we can cancel out the G's on both sides, and this will show the fraction of ice underwater, which is given by the ratio of density. W is equal to PW over PI, and we can rearrange for VW, which is what we're looking for. So VW is equal to VI over PW. So, and we can plug in the values now, which would be equal to 917 over 1020, which is 0.9. And this means that 90% of the iceberg's volume is submerged underwater. So we can do 1 minus 0.9, which means that 0.1 VI is above water. So that is the fraction of the iceberg that is above water.